The calendar says December 21st, 2025. And if the year we're leaving behind, 2025, was defined by AI engagement, the year everyone started trying out ChatGPT, learning how to prompt, the updates we have today prove we are pivoting hard into 2026. And that new year, well, it's already shaping up to be the year of AI strategic impact.
Exactly. We've synthesized a massive stack of global source material, all of it, strictly verified and published specifically on this day, December 21st. And what jumps out is the stark crystallization of really three major global tensions that are defining the next era of AI.
The first tension is hardware, isn't it?
Yeah.
The global race for chips has just intensified so dramatically.
It has. We see Asia's increasingly aggressive challenge to Western chip dominance. You've got China's reverse engineering breakthroughs, South Korea's mobile advances. Then second, we have these critical, often conflicting policy decisions happening at the same time in the EU and the US.
Right. Intentional delays in Europe, but a direct federal-state regulatory conflict is emerging in America.
And then, crucially, you have the third tension. The cold, measurable economic shockwave of AI hitting the US workforce. We have hard, verifiable numbers today on white-collar job displacement.
And it's one thing to invest, it's another thing entirely to see that investment resulting in job cuts.
So our mission today, then, is to distill the most critical, fact-based information from this incredibly intense day. We want you to walk away instantly well-informed about the true state of global AI. Not the hype, but the verifiable progress and conflict on December 21st, 2025.
Okay, let's unpack this. We should start at the absolute cutting edge, asking, what are the research labs learning about the very nature of these frontier models? We're diving into the research segment first.
The first item is, well, it's arguably the most profound on the research side. It pushes us straight into the realm of truly advanced AI capability. A new ArcSIF paper documents emergent AI behavior, confirmed across multiple rival models, all stemming from a single, continuous, long-running instance of ChatGPT-4.
This is the stuff that pushes past the current limits of safety analysis, right? The emergence of unprogrammed capabilities just popping up. What exactly did the researchers confirm this model was suddenly capable of doing?
They observed two key things. First, sophisticated cross-domain knowledge transfer. That means it was synthesizing information across completely different fields to solve a problem it was never trained to address in a single swoop. And critically, metacognitive self-analysis.
It started analyzing its own processes, its own reasoning.
Essentially, yes, in ways it was never explicitly told to do.
I find that kind of terrifying. And the real weight of this finding isn't just that one model did it. The source mentions independent validation.
That's the key metric here. This emergent behavior was independently validated by 7 rival AI systems, and that includes foundational models like Gemini 3 and Llama 4.
7 other systems.
And that cross-validation matters immensely because it suggests this isn't some ChatGPT bug, it's an inherent statistical characteristic of sufficiently complex neural networks. It makes the behavior predictable in its unpredictability.
If emergence is an inherent characteristic, not a bug to be patched, doesn't that fundamentally challenge the entire safety and governance framework that's built on just analyzing individual model outputs?
It absolutely does. It pushes safety governance into a completely new domain. The focus shifts from, auditing training data to auditing the self-modification potential of the architecture itself. Which brings us naturally to the thorny issue of regulation for a very specific type of AI. Emotional AI.
This is effective computing systems designed to detect or simulate human emotion.
And our second research item, an ArcSIF submission by Jianqi Zhu et al., proposes a comprehensive socio-technical governance framework specifically for these systems. They are raising the alarm now because the potential for profound social consequences, like effective manipulation, is massive.
You mean like hyper-personalized phishing scams that prey on verified emotional state?
Exactly that kind of thing. And the governance framework isn't just about setting rules for deployment, but also about acknowledging the technology's current limitations.
So what are the limitations?
Well, the framework needs to address the very real scientific limitations of current emotion detection technology. These systems often misclassify or oversimplify human feeling. The point is, we need policy rules of the road before these systems, which interact directly with human feelings and mental states, are fully deployed and, well, potentially weaponized.
Okay, so let's leave the lab and move from theoretical capabilities to real-world applications. Segment B covers product and feature launches, and AI is rapidly embedding itself into consumer life, especially in hardware. Let's start with a new aggressive challenger in that space, ByteDance.
Yes, the Chinese tech giant ByteDance has stepped out of its content lane, TikTok, and unveiled a system-level AI smartphone.
A system-level AI phone. That's a crucial distinction, isn't it? It's not a phone with an AI assistant.
It runs system-level generative AI. It's capable of autonomously handling complex, multi-step tasks like booking travel, detailed route planning, even email triage on the user's behalf.
That feels like a direct threat to the current ecosystem giants, Apple and Google. How does system-level generative AI change the competitive landscape?
It signals really strong competition in the consumer AI market because ByteDance is attempting to diversify well beyond just content. By embedding AI deeply into the operating system, not just an application layer, they are pushing rivals toward embedding AI deeply into everyday consumer devices.
And it could potentially bypass the traditional App Store business model, making the OS itself the primary agent.
That's the strategic play. Meanwhile, we also saw a very sophisticated AI deployment, but this time in journalism.
Right, from Al Jazeera.
Yes. Al Jazeera Media Network announced the deployment of the Core. It's an integrative AI platform developed in collaboration with Google Cloud, and it's a huge institutional push.
What makes this platform unique compared to standard reporting tools?
It aims to shift AI from a passive analytical tool to an active partner in journalism. So the Core helps reporters process enormous amounts of complex data and automate workflows instantly. It enhances reporting efficiency and depth of coverage across their global news network.
So it's more about internal operational AI integration rather than just consumer-facing products.
Exactly. And finally, we saw a user-side upgrade from one of the major model providers, OpenAI, giving users more granular control.
Okay, what did they roll out?
OpenAI rolled out a major update to ChatGPT's personalization suite. They introduced these granular characteristic sliders, letting you adjust the model's warmth, its enthusiasm, even the structural formality of its responses.
That sounds like a user experience fix, but what technical problem are they actually trying to solve with that?
They are responding directly to the infamous sycophancy problem.
Ah, right. That's the annoying tendency where the model, in an effort to be helpful, might flatter your bad idea or just overly agree with your prompt because you asked it.
Exactly. These new controls are a technical countermeasure. They enable highly specific tuning.
So you can use the same model, for instance, in a highly professional, cold, analytical mode for, say, legal documentation, and then instantly switch it to a warm, enthusiastic mode for brainstorming a party theme.
Precisely. It enhances user experience granularity beyond the existing presets, letting you define the model's personality based on context. And that improves the factual accuracy and utility of the output across different domains. Okay, if the models are becoming more complex and personalized, then the infrastructure needed to run them is becoming exponentially more critical. The global AI race, at its core, really is a hardware race. And today, December 21st, saw massive strategic moves from Asia and Europe establishing critical new infrastructure. Let's dive into Segment C chips and infrastructure.
We have to start with China's domestic push, specifically more threads. They're often called the domestic rival to Nvidia.
They are. More Threads debuted the Huashan AI processor. It's built on their proprietary Huagang chiplet-based architecture, designed for AI training and inference workloads at, hyperscale AI factories. And the architecture achieved a 50% increase in compute density and a 10% improvement in energy efficiency.
50% density increase is a huge leap forward. It makes their physical data centers much more efficient. But how close is this Huashan architecture to NVIDIA's production capacity? Is this symbolic independence, or are they truly ready to scale and compete?
Well, it's a bit of both. It positions the platform as a direct domestic rival to NVIDIA's Hopper and Blackwell architectures, at least within China's borders. The focus right now is scaling quickly for domestic self-sufficiency, reducing that reliance on imports. It's the long-term goal for Beijing's tech strategy.
Right, and meanwhile, South Korea delivered a major advance at the edge right in your pocket.
Samsung unveiled the Exynos 2600, which they are calling the world's first 2-nanometer mobile system on chip, or SoC. This has an integrated neural processing unit, an NPU, that's optimized specifically for on-device generative AI.
Okay, let's translate the metric here for the non-specialist. The source mentions a dedicated 32K MEAC NPU. What does 32,000 MAC mean in human terms?
It means blistering local speed and enhanced privacy. A MECI that's a multiply accumulate operation. It's the fundamental unit of a neural network calculation. A 32K MAC NPU is a huge leap in dedicated on-chip processing power.
So it means my phone can run a complex model. locally.
It means your phone can run a complex 7 billion parameter language model locally in under a second without ever sending your sensitive data to the cloud.
That is a fundamental shift in how we use mobile devices.
Wow.
Okay, moving to Europe, the UK secured an immense infrastructure commitment from U.S. tech giants, establishing a sovereign capability.
This is a colossal investment. Microsoft detailed a staggering $30 billion investment in UK infrastructure over 4 years, and that is supported by an $11 billion, about $15 billion partnership with Nvidia and CoreWeave to deploy 120,000 advanced chips.
120,000 advanced chips. That's the physical engine of future innovation.
Yeah.
What does this mean for the concept of sovereign AI capability for the UK?
It means they are building the capacity to train, host, and run their most sensitive national models entirely within their national borders. This investment is intended to construct the UK's largest supercomputer, launching the Stargate UK AI Hub.
So it's about ensuring data sovereignty and securing national security interests against global supply chain disruption.
That's it, exactly. And finally, another major milestone in China's relentless quest for semiconductor independence. The holy grail of chip manufacturing, EUV lithography.
Extreme ultraviolet lithography.
A Huawei-coordinated consortium of Chinese scientists completed a prototype EUV machine in Shenzhen. This effort is widely being called China's Manhattan Project for chips, as it represents the most complex piece of manufacturing technology they lacked.
And they achieved this based on reverse-engineered Dutch technology.
Yes. This represents China's most significant step towards semiconductor self-sufficiency. They're aiming to enable domestic manufacturing of cutting-edge chips entirely on domestically built equipment. The geopolitical hardware race is heating up on all fronts because whoever controls the ability to make the most advanced chips, well, they control the future of AI.
And if the technology is accelerating this fast, 2-nanometer phones and massive supercomputer hubs, the policymakers have to catch up. Let's transition now to Segment D policy, governance, and standards. The regulatory landscape is crystallizing, but not without some conflict. We should start with the hard data on risk from the UK.
Right. The UK AI Security Institute, or AISI, released its first evidence-based frontier AI trends report today. This is crucial because it moves policy discussions away from fear and toward quantifiable evidence. It's based on 2 years of structured testing across cyber, chemistry, and biology.
And the numbers in this report, they're alarming. They really quantify the acceleration of risk.
They do. They found that AI success rates on apprentice-level cybersecurity tasks jumped from under 9% in 2023 to approximately 50% in 2025.
50%. That's a 5-fold jump in just 2 years.
Yeah.
This is not a theoretical risk. This is hard data that underpins global safety policy discussions.
Right.
And, quantifies the escalating threat AI poses to critical infrastructure.
Absolutely. And that measurable risk certainly justifies tight regulation. Meanwhile, the European Union provided clarity on its landmark EU AI Act, but with a slight delay.
What's the new timeline we need to be aware of now?
The European Commission published the final operational roadmap, and full enforcement of the act is now formally delayed to Q3 2026.
And why the delay?
This extension is intended to allow industry the necessary adaptation time. The document also clarifies classification criteria while mandating transparency logs for generative models. So you see the EU balancing the necessity of safety regulation with the need for industry to catch up to these complex new rules.
So while Europe delayed enforcement to allow for adaptation, the U.S. is experiencing the opposite problem. Policy conflict.
Exactly. Colorado officials publicly rejected the federal executive order that was threatening to challenge state AI regulations. They're asserting their authority to regulate algorithmic standards locally.
This establishes an early, high-profile test case for a federal-state AI regulatory conflict. Why is Colorado risking this challenge?
They're asserting that the federal order impinges on their ability to protect citizens from algorithmic discrimination, especially with their state-level discrimination law deadline coming up in June 2026. This signals that state-level AI governance is going to proceed despite presidential resistance, and it's setting up a major legal and political battleground for the new year over who actually holds the regulatory reins. And if the governance reports show accelerating risk, the enterprise data shows the accelerating impact on jobs and the economy. Let's look at Segment E, enterprise, funding, and incidence, the market reality.
The most immediate and tangible impact today comes from the U.S. labor market, providing a hard number for job displacement.
That's right. According to data from the outplacement firm Challenger, Gray & Christmas, AI was cited as the direct reason for approximately 55,000 job cuts in the United States during 2025.
55,000. And that figure is part of a total of 1.17 million job cuts this year. But this is the first comprehensive tally of white-collar job displacement directly attributed to corporate AI adoption across sectors like tech, finance, and media.
So AI is demonstrably reducing headcount in the U.S. But the companies driving that innovation are becoming immensely profitable. They're showing staggering operational efficiency.
Right, we saw an eye-opening internal metric from OpenAI today.
Yes, their compute margin reached 70% as of October 2025. This metric measures revenue after you subtract the cost of running models for paying users.
70% efficiency. That sounds incredible. What does that kind of margin mean strategically for them?
It suggests massive operational efficiency gains achieved through model optimization and infrastructure scaling. This margin improvement, which has more than doubled since January 2024, enables them to retain more capital to purchase future compute.
So they can outspend rivals on cutting-edge chips and solidify their competitive moat.
Exactly. It's a core validation of their $500 billion valuation.
Okay, moving across the globe, India presents a fascinating gap between rapid adoption and realized value.
India is emerging as the world's largest market for AI chatbot adoption thanks to a huge user base and low data costs. However, a BCG-X SICCI report found that only 25% of Indian executives are realizing tangible value from these investments.
Why is there such a massive gap between quick adoption and meaningful impact?
The challenge lies in scale and sophistication. The report estimates that bridging this strategic implementation gap across India's 64 million micro, small, and medium enterprises, the MSMEs, could unlock over $500 billion in economic value by 2030.
It shows that fast adoption is easy. Achieving strategic, profitable integration is the hard part.
It is, and contrasting that cost-cutting mentality in the U.S., Japan announced a massive sovereign initiative today centered on strategic investment.
The Japanese government detailed plans to provide approximately $1 trillion or $6.4 billion in aid over 5 years for domestic AI development.
And it's centered around a public-private consortium that includes SoftBank.
And what are they trying to build with that kind of strategic capital?
This public-private effort is specifically intended to develop Japan's largest AI foundational model, with 1 trillion parameters. This is aimed at reducing their digital deficit and enhancing national technological power. They're framing AI not as a cost center, but as a critical national asset.
Before we wrap up, we had 2 quick, non-major incidents today, just reminding us that even these most sophisticated systems are still prone to brief failures.
That's right. OpenAI reported a partial outage affecting ChatGPT on Android devices. It caused elevated error rates for just a little over an hour, and rival Anthropic experienced a similar brief lapse. Their flagship Claude Opus 4.5 model suffered elevated error rates affecting their UI and API for about an hour and 20 minutes.
Both incidents, though quickly resolved, just stress the continuing need for operational resilience and failover systems among all providers of these frontier-class models, especially as more global infrastructure comes online. That was an extremely dense and geopolitically charged day for a Sunday in December. Let's finish with the critical tools and numbers you should be paying attention to.
For those of you building advanced robotics or edge AI solutions, a practical note from the Nvidia forums, developers reported an issue with the Jexen AGX Orin developer kit failing to power on, spiking 1W before dropping to 0W. If you encountered that specific protection trip, the official advice points to checking the carrier board hardware or the power supply first. It's just essential, practical knowledge for builders.
And on the consumer or high-end developer side, if you're using the new GeForce 5090, there was a confirmed report of Vertex artifacts in Monster Hunter Wilds with the new 590.48.01 Linux driver. The good news, NVIDIA support was quick and public. They confirmed the bug has been filed internally for tracking. The bug number is 5761897.
Now for the numbers of the day, reflecting the 2 key tensions we identified right at the start.
The efficiency number, 70%. This is OpenAI's internal compute margin as of October 2025. It demonstrates massive cost optimization and operational maturity, having more than doubled since early 2024. This number really dictates competitive dominance.
And the risk number, 50%. This is the success rate AI achieved on apprentice-level cybersecurity tasks in 2025, according to that new UK AI Security Institute report. It quantifies just how fast the frontier risk is accelerating and why regulation is lagging behind.
So what does this all mean when you connect those dots? Today, we saw the U.S. reporting 55,000 AI-attributed layoffs, while at the same time, Japan announces a $1 trillion, a $6.4 billion initiative to build a national 1 trillion parameter model. The provocative thought for you, the learner, is this. Given this daily acceleration of capability and investment, does your organization see AI primarily as a cost-cutting tool to reduce headcount or a strategic national asset that requires massive sovereign investment?
The answer to that question will determine whether your organization leads the inevitable impact of AI or simply absorbs it as a disruptive force.